Welcome back, algebra students. In this video, we will solve an equation with this idea or this process called U substitution. And really, the U is not as important as what we're actually doing with the U. So really, you could use any variable that you want to in this problem, but we typically use U because it's something that you might see later on. So the idea here, the goal you might say, is to convert a challenging equation to an equation that is more familiar. So for example, if you had, and this is really not the best example because you could solve this pretty easily without doing U substitution, but it gives you an idea. First of all, typically you say let U equals and you determine what U equals. So here's an equation. Let's say I had 2x minus 3, 2x squared minus 3 rather, sorry, is equal to 47. So here in this case, I could maybe say let U equal x squared. So now I have 2u minus 3 is equal to 47. So I have taken out the x squared and replaced it with u. And I'm going to solve this now for u. So I'll add 3. So I have 2u is equal to 50. I'm then going to divide by 2. And so I have u is equal to 25. But now at this stage, I'm going to put the x squared back into my equation. Because remember, you're not solving for u. You are actually solving for x. So I have x squared is equal to 25. So x, you square root both sides, and so x is equal to plus or minus 5. So again, that's an idea, or that's an example of how to do U substitution, but you probably would typically not use it for this particular equation. In these two equations, what we have are equations that can be written into quadratic form. And I recognize this because of the exponents for both of these equations. So what I'm going to do is use substitution, and I'm going to convert them into quadratic form. So again, I start with that statement of letting U equal something. And whenever I can convert it to quadratic form, I look for U to be that middle term, that middle variable. So in this case, x squared. So that gives me negative 10u. Plus 25 is equal to 0, but notice I didn't include the x to the fourth. So just off to the side, I know that x to the fourth is the same thing as x squared times 2, so and then that can be rewritten as x squared and then squared with parentheses. Well, then this, I can substitute u for x squared, so I have really u squared. So x to the fourth is really u squared, and now I have a quadratic equation which I can in fact solve. So I'll do this by factoring. So we have u and u, 5 and 5, minus and minus. So u in this case is equal to 5, which means x squared is equal to 5. Now I didn't write that twice because I have the same solution twice. It's what we call a repeated solution, and you don't need to do it twice. And so I square root x and square root 5, and so I have x is equal to plus or minus the square root of 5, and that is my solution. Same thing happens for number 2, the second problem. So we will let u equal x to the 1/4, and here's the thing, we know that x to the 1/4, if we square that, we do actually get x to the 1/2 because you would be multiplying the 1/4 and the 2 to get x to the 1/2. And so that means we have u squared minus 3u plus 2 is equal to 0. And again, I choose to factor this, so it'll be u and u in the first terms of my binomial. I know it'll be 2 and 1 minus and minus, so then u is equal to 2 and u is equal to 1. But I'm not done because I need x to the 1/4 is equal to 2 and x to the 1/4 is equal to 1. Now, what you may not realize, so I'm going to show you two ways to do this. First of all, you could raise this to the 4th power for all the way around for each side, and this will cancel out the exponent of 1/4 and the exponent of 4, because 4 times 1/4 is 1. So x to the first and x to the first, which is great. So 2 times 2 times 2 times 2 is 16, and 1 times 1 times 1 times 1 is 1. So your two answers are 16 and 1. However, you could convert the x to the 1/4 into the 4th root of x is equal to 2, but you would still take the fourth power of both sides, it would still cancel these out, so you'd still be left with x is equal to 16. So two different ways to look at that. Either way, you get 16 and you get 1 for your two solutions. Number 3, again, is still in quadratic form, but it doesn't look like it. So the first thing I would like to do with this equation is square both sides to get rid of one of the square roots. So we are left with, on the left side, 3 minus 2 times the square root of x, and on the right side it actually cancels out the square root and you're left with x. Now believe it or not, this is actually quadratic form. So what I'm going to do is let u equal square root of x, which means that if you square u and square the square root of x, that means u squared is equal to just simply x. So I will have 3 minus 2 times u is equal to u squared. And again, I have quadratic form. So I choose to get this equal to 0, and I also choose to have the u squared be positive. So I'm going to subtract 3 and add 2u to both sides. So that gives me 0 equals u squared plus 2u minus 3. And so I will factor this to solve. Of u and u, 3 and 1, and this will be plus and minus. So now I solve and I have u is equal to 3 and u is equal to positive 1. Sorry, that's negative 3. And so finally I know that my u was actually square root of x is equal to negative 3, and square root of x is equal to positive 1. Now this presents a bit of a problem because the square root of x can never equal a negative value in the set of real numbers. So I know that this is not an actual answer. This will produce an extraneous solution. Okay. However, this, the square root of x is equal to 1, is possible. Square both sides, and what you find is that x is equal to positive 1. So this is, in fact, my only solution to this equation.
Strawberry, I love you.